Hello guys, welcome to Physics Unlocked, and I'm here with very interesting problem of physics. And this problem is taken from INPHO 2007. So in this problem, a spherical small ball undergoes an elastic collision with a rough horizontal surface. Before the collision, it is moving at angle theta to the horizontal. So in this case, we are given a small spherical ball. So this is moving initially with v0 velocity, and it is making an elastic collision with this rough surface at an angle theta to it. So initially its x component velocity will be v0 cos theta, and its velocity in y direction is v0 sin theta. So it is the situation just before the collision. So during the collision, when it will strike this surface, so there will be an impulsive normal in y direction, and since this point has tendency to move in forward direction, so there will be a tendency to slip in forward direction. That's why the friction will act in backward direction to this spherical small ball. There will be friction in backward direction, and friction will be at its limiting value. So mu naught n friction will be acting in the backward direction throughout the collision. Let me assume this collision occurs for very small time dt. So throughout the process, these two forces are going to act on this spherical ball. So there will be a normal in y direction and friction mu naught n in leftward direction. So this is the situation just after the collision. We have assumed that after the collision, a spherical ball is moving with vx speed in x direction, and its speed in y direction is vy. So let me proceed on the next page. So this is the situation. Initially it is moving with this much velocities, and after the collision the ball is moving with vx and vy. So since the collision is elastic, so the coefficient of restitution will be 1. So the velocity of separation, that is the vy, will be equal to the v0 sin theta, that is the approach velocity of approach. So vy will be v0 sin theta. Now if we write the impulse momentum theorem in the y-axis, since there is an impulsive force in y-axis n, and it acts for dt time, so we can write the impulse of this force. Integration of n dt will be final momentum minus initial momentum. So the value of n dt from here will be 2 mv0 sin theta. So now if we write the impulse momentum theorem in x-axis, so there is an impulsive force in the minus x direction. So the impulse of this force will be minus mu naught n dt, and this impulse can be written as final momentum in x direction minus initial momentum in x direction. So the final momentum is mvx minus initial momentum. So if we substitute the value of n dt from the first equation to the second equation, so we have minus mu naught 2 mv0 sin theta will be equal to mvx minus mv0 cos theta. So from here we can calculate the value of vx in terms of cos theta and sin theta, mu and v0. So the only variable here is theta. So we have calculated vx in terms of theta. Now horizontal range will be time of flight into x component velocity. So its time of flight will be 2 v0 by g into vx. The value of vx is this. So the range will be this much. As we observe here, so range is the function of theta. So range is function of theta. So if we have to maximize the value of range, horizontal range, we will differentiate it with respect to theta. and we will equate it with 0. So if we differentiate the expression of r with respect to theta, so we will get, so we have the expression of r in terms of theta. This is the value of r, and if we differentiate it with respect to theta, so this is the differentiation dr by d theta. On equating it with 0, we will get the value of cot 2 theta equals to 2 mu. So from here we can get the value of theta is half cot inverse 2 mu. So this is the value, this is the theta m for which the horizontal range of this small spherical ball will be maximized. So this is the value of theta m. So as we know, the value of coefficient of friction can vary from 0 to infinite. So on plugging the value of coefficient of friction in this equation, we can get the value of theta. So theta will vary from 0 to pi by 4 angle. So this is the required solution of this problem. Thank you.